created before, and if you want to create more loss, so we play with the gates. Maybe gates are open a little bit more, so there will be more loss. So this is how we calculate the loss of the energy in this open channel with the help of the hydraulic jump. So what are the important here? So what is the hydraulic jump? Hydraulic jump is artificial, created by engineers for killing or reducing the energy in the channel to make the structure safe. How it is created? It is created with the help of two gates. It is created with the help of two gates. One gate is here, one gate is resistor. And this gate is open like this one is smaller, and this gate is open axial, fine, from flow. So now the flow goes like this one, and after striking it jumps and it falls here. So this mantaka is the hydraulic jump. Here you'll see like the water is jumping. There will be jump like shakal. It will be like a jump. This is the water jump, and this depth is y2. Then you jump after length after the jump, and this that y1, and these y2 and y1 will tell how much energy is lost here and how much power is lost here. Now, what is the shart? What is the this is not ID. It is created. So what is the condition of creating a hydraulic jump? There must be some shart. So the shart is that this y1 here velocity should be very high. How you know very high? We know with the help of the Froude number. Yani Froude number must be aktar min wahadina. Yani flow must be supercritical. Right? And velocity after the jump should be very low. Yani Froude number must be akal min wahad. Yani the flow must be the subcritical. So this is the shart of the hydraulic jump. So the flow must change. Flow should change from supercritical to subcritical flow. This is the shart of this hydraulic jump. Unless their flow is supercritical coming and subcritical going, there will be no jump. So this is the condition. Mathematically it can be like the incoming flow must be more than Froude number 1, and outgoing, and after the jump the flow should be Froude number less than 1. This is the shart of the hydraulic jump. The incoming flow must be supercritical, and the outgoing, and after the jump flow should be the subcritical. So where is the critical? Because as I explained in the RAD tutorial, every channel has all three types of the flow: critical, subcritical, and supercritical. Critical at a muhaddad depth. So in this one, how can I explain like this? Suppose that this is the hydraulic jump, and this is the depth after the jump y, and this one is the y1. Here is the gate. This is the hydraulic jump area. So here in this hole, min hina ila hina, this flow is the supercritical, and from here to this is the subcritical. And here Froude number is less than 1, and in this mantaka Froude number is aktar min wahad. So this is the supercritical zone, and this is the subcritical zone. So where is the critical? Critical is at a muhaddad nokta. This is the transition, like hydraulic jump is a transition also. It's changing from super to subcritical. So maybe at some muhaddad, this may be the critical depth, yani YC. Fine. So this will again, it will, it will behave like super, and from here it will behave like the subcritical flow. If you remember, in that I explained you last time in a channel. Let's take the cross section of this one. Suppose that the Y critical depth is here, yani Froude number jiddan wahad. So the below depth here, all is the Froude number aktar min wahad, and flow will be supercritical, and for all the depth will be less than Froude number 1, yani subcritical. Why? Froude number has alaka with the velocity under root GD. See, The velocity has direct relation with the Froude number. So what happens here, if the velocity critical is here, right, and Froude number is yani wahan, so if you go ahead, so the depth is decreasing. Depth is decreasing, so velocity is increasing. If velocity will increase, then Froude number will increase, and it will become more than 1 because 1 is here, sir. So this will become supercritical mantaka. And as you go, velocity will decrease because cross-section depth is increasing, so the velocity is decreasing. If the velocity decreases, Froude number will decrease because it is directly proportional. Velocity is directly proportional to the Froude number. So this is the concept. Again, I explain you. Okay, what is the hydraulic jump? It is artificially created in the channel to reduce the energy or to kill the energy with the help of two gates. The flow, what is the condition of the hydraulic jump? The flow, incoming flow must be supercritical, yani Froude number more than 1. And the outgoing flow, yani after the jump, the flow depth should be, yani the flow should be subcritical, yani velocity should be less. Subcritical, yani velocity should be less. How you know? With the Froude number. So Froude number must be less than 1, means flow should be the subcritical. This I am talking about this zone. And Gabel jump, it should be supercritical flow, yani Froude number must be more than 1. This is how we calculate in this one. And then there is a formula to calculate, okay, what is the force on this boaba? It is given in this slides, you can check. So let me go back to the slides. Okay, so this is the object which is given, and here are the rums. Specific energy, because specific energy also here is required because there is a graph required, specific energy diagram. I will explain you. Specific force, water depth, Froude number, channel width. Go to the next page. This is the what I explained you. This is not required in the report, just to explain how it is working. So I can send all this. It is the page required, basic theory. Now see the basic theory. Equation is here. This is the equation of the head loss. HL out delta E is equal to Y2 minus Y1 whole cube upon 4Y. And with the help of this one, you calculate this is the gamma. Gamma is equal to rho G. Gamma Q delta E out H. So yani PL, as I explained, would be gamma Q HL. HL is equal to delta E is the same thing. The unit of this power is equal to the watts, and this is the meter. Now there is a ilaka between the y1 and y2, and depth before the jump, that is called the conjugate. The y2 ala y1 is equal to 1 by 2, 1 plus 8, Froude number 1 square minus 1. Jump length, height, y2 minus 1. Jump length is equal to 5 into height of the jump. Yani the length, normally the length of the jump remains 5 times the height of the jump. Height of the jump means what? Y2 nagis y1, yani what is the depth of the water after the jump? Nagis what is the depth before the jump? Froude number V under root GB से किल मौजूद है ना, channel and your kata test procedure किल मौजूद. Just you copy all these things, and then next will be the data sheet. This is the data sheet. Okay, you can copy all these also. Here is a data for the graph. The graph, 2 graphs are required. 2 graphs are required, like this one. Between depth of the flow and ES and Fs. Both are given equations. Both these equations are given here. That will help you to calculate where this is here. Shutta. Fs is also given and ES is also given. And the third jadwal is here, where we take the theory points like this one. So these are the points. So this will go on like this one. See, with this data, I am explaining you how to plot the graph. Here will be ES, this also, and Fs. Fs. Yes. So first, when we take the graph between these two, your graph will be something like, it will be something like this one. This is the specific energy diagram between Y and Es. Then when you take the between Y and this one, specific for, the graph will be something like this one. So these are the two graphs. This is the Es, this is the Fs. This point is the critical point and this depth is critical depth. And we can calculate the critical depth, and this is the minimum energy, E minimum. We can calculate the critical depth of minimum energy through the graph also. So the equations I explained you in the tutorial, and also I sent you some homework. So there are two methods to calculate the Y critical minimum energy, one through the equations, one through the graph also. The second method, in the laboratory, we calculate through the graphs. With this graph, you see the last page of the graph, in this one, after plotting the graph, this is the specific energy diagram, the green one, and the red one is the specific force diagram. So in the specific energy diagram, this critical nokta, yani the point from where the graph is changing, it is coming like this one, then changing, coming like this one, then it is changing. So this is the point is critical. So this critical point will give you the critical, and this critical point will give you the E critical or E minimum. This minimum energy is this one also, because there is no energy for minimum energy, critical depth. And here fruit number is jiddan wahid because it's critical. So min hina ila hina hadi kulli depth is super critical. Yani fruit number is akal min wahid, and fog min hina hadi kulli subcritical zone. Yani fruit number is hina fruit number, sorry, tahat fruit number akal min wahid supercritical, and fog fruit number akal min wahid because it's subcritical. So through the diagram also, diagram is like a mulakhas. It will tell you everything. Similarly as equations, everything you can calculate with a diagram. Once again, I will explain you this diagram because I think Dr. Faisal and Ibrahim will also teach you. What is the meaning of this diagram? We plot the diagram of the specific energy like this one. Here is the ES, specific energy, yani Y plus V tarbiya ala G. Muqabil depths. Y. When we take the plots, it comes like this one. So this is the specific energy. Now, in this diagram, what is, see, that coming and here and then changing this direction. So the critical point is this one. This we call as the critical point. So at here the fruit number jiddan wahid, and this depth is now Y critical, and this energy min hina ila hina, this is the energy E critical or E minimum energy. And from here, because it's the critical point, tahat depth is akal. So fruit number is high because velocity will be more. Depth less, velocity more, fruit number will be more. So this is the supercritical. And for it is velocity, depth is more, yani Y is more, yani that velocity is less comparatively. So the fruit number will also decrease less than 1, yani subcritical. So see, in the same channel, you have the supercritical, critical and subcritical, all three types of the flow. So as I explained in the questions or Madala also, through the equations also we calculate, and through the graph also we can calculate. So this is one of the experiment. You have to draw the graph that will help you to draw and to understand what is the critical and what is this one side. Conclusion and the discussion that you have to write. So what you will write in the discussion? In the discussion you can write like what is the condition of creating the hydraulic jump. As I explained, the condition is that the flow must be changing from supercritical to subcritical, yani from fruit number more than 1 to fruit number less than 1. This is the one thing. Second thing, what is the use of the hydraulic jump? It is used to dissipate the energy, yani reduce the energy in an open channel. Okay. And then what is the supercritical flow? Supercritical flow is that when the fruit number is more than 1, yani the velocity of the channel flow is very high. At that point, it is supercritical flow. What is the subcritical flow? If the velocity of the flow is very less, and if Froude numbers becomes less than 1, that's the subcritical flow. And what is the critical flow? Critical flow is the flow where the Froude number is absolutely wajib than wahad. That flow is called as the critical flow. Why it is important? Because at the critical point, the energy will be the minimum Akansha energy. This you can put in the discussion, and conclusion will be muhaddad, because it is muqabil to the object. The object was what? Calculate the energy loss and the power loss. So through the jadwal, when you calculate, you will get how much is the energy loss and how much is the power loss. That you can put in the conclusion. Experiment complete. I will send you all the required sheets inshallah tonight, so that you can complete your taqreer. And then you send the report, must write on the Raisi Varga of the report, not in the email. Raisi Varga, as you submit the hard copy, your name, your ID, and section. Some students are not writing, they are just in the email. So I don't have time to go back and check all the email. I will see the reports. Please, if you have not done before, so resend it, any report. But most of that you have already submitted. So check when you are submitting. Next experiments will be included. Next quiz 4, 5, 6. 4, 5, 6. And see, the orifice and the Venturi meter. The only difference between the orifice and the Venturi meter is their uses. Sahih? Orifice is used in the tanks, and the Venturi meter is used in the, So if I ask some question, this they are the same thing, and their coefficient of this discharge is the almost same. They don't change with anything other than. Fine. So Venturi meter is experiment number 4 or 3? Are you sure? Venturi is the experiment number 4, I guess. So today, have you studied the Venturi or no? You not studied? So I give you the hint, because maybe some 1 or 2 questions. The coefficient of discharge is Venturi is also same as the Okay, so let me change that question. Okay, so now I stop this session here, and it's 3:39. Fine, 3:39. So quiz when you want to start, 3:45 or let it 3:50, because I just need to change the Venturi question. I think I put 1 or 2 by mistake. So let it be 3:40, Shabab. Okay, is okay. Start the quiz at 3:50. Fine.